Today we're going to talk about greatest common factor, often called the GCF. G for greatest, the largest. Common, C, the one that happens in both or in all. And factor, think of a factor as a piece, or you fracture something, you break it apart. That's exactly what we're going to do. There's two methods that we're going to use for this. One is the tree diagram, and one is what we call the ladder. After I show you, you'll have the choice to do whichever one you like better. So let's start with an example. We want to find the greatest common factor of 12 and 18. Okay, what's the biggest piece that I can find that is in both 12 and 18? So if I'm going to do it with the tree, I need to make trees for each individual one. Trees are nice because you can use any factor. You don't have to start with a prime number or anything like that. So what's two numbers that will multiply to give me 12? We got a couple options. I'm going to go with 3 and 4, right? Because 3 times 4 is 12. Can 3 be broken down? No, it's prime. It's only 1 times 3. So I'll circle it because there's nothing else I can do with it. Can 4 be broken down? Yeah, I can do 2 times 2. So I'll split it. Can the 2's be broken down? No, those are also prime. The only factors are 1 and 2. So my prime factorization for 12 is 2 times 2 times 3. Often we'll write them in order from least to greatest. You might even see it written with exponents. Because there are 2 of them here, I'll put a little tiny 2 above it. Okay, let's do 18 now. Again, I have some options for 18. I think I'm going to do 2 times 9. The 2 is prime. It cannot be broken down. The 9 can be split into 3 times 3. Those cannot be broken down. So 18 is 2 times 3 times 3. Or if you wanted to use the shortcut exponent, it would be 2 times 3 squared. Now, to find the GCF, I need what is in both. It must be in both problems for me to count it. So I see there's a 2 and a 2. There's a second 2 in 12, but there is not a second 2 in 18, so I'm not going to circle that. I see that there's a 3 and a 3. It happens in both. There's another 3 over here, but it's not in the 12, so I'm not going to count it. So my GCF is 2 times 3, or 6. The biggest number that would divide into both 12 and 18 is 6. All right, so there's this other method called the ladder. Some people call it the stair step or the birthday cake, or there's a bunch of different names for it, but the steps are the same. You take the numbers that you have and you write them side by side with just a little bit of space between them. I'm going to do this like weird upside down division thing. I need a number that divides into both. I'm going to start with 2. That's always a good number to start with. And then it's like this weird upside down division thing. 12 divided by 2 is 6, so I'll put that right underneath of it. 18 divided by 2 is 9, so I'll put that under the 18. And then you ask yourself, is there anything in common? Can I divide both numbers by the same thing? Well, yeah, 3 will work. So I'll do another level, another layer, another rung. I have 3 that will divide into both. 6 divided by 3 is 2. 9 divided by 3 is 3. Before you make that next layer, is there anything that will divide into both 2 and 3? No, 1's the only number, and that's not going to get me anywhere. So the GCF is the stuff on the side multiplied together. And again, we got 2 times 3, or 6. It didn't change my answer. Now, a fun tidbit for you. Let's switch colors of highlighter here. When you get to the bottom and the greatest number that you can divide is 1, these are what we call relatively prime. When the biggest common factor, or the GCF, When there's nothing else that can divide into both, they are relatively prime. Doesn't mean that they're prime numbers. It just means that together there's nothing in common. All right, let's do one more example, and I will show you both the tree and the ladder. Let's do 12 and 66. We want to find the GCF of 12 and 66. If you prefer the tree method, you have to make a tree for both. I've always liked the tree method because I can pick any numbers. I might pick 2 and 6. Mrs. Kennedy might pick 3 and 4. And that's totally fine. We end up with the same answer at the very end. All right, so I'm going to do 2 and 6. 2 is prime. 6 is 2 times 3. They're both prime. So 12 is 2 times 2 times 3. 66 is 6 times 11. Well, 11 is prime. 6 can be split into 2 and 3, and then they are prime. So 66 is 2 times 3 times 11. Now, when I look for the things that are in common, they have to be on both. So I've got 1, 2. I've got 1, 3. There isn't a second 2, and there isn't an 11. So again, our GCF is 2 times 3, or 6. You don't have to do both methods. Pick the one that you like, pick the one you're comfortable with, and stick with it. Okay, so for the ladder, I'm going to put the numbers next to each other. Draw my rung. Find something that's in common. I don't know. 2. It's always a good place to start. 12 divided by 2 is 6. 66 divided by 2 is 33. Is there something in common? Yes. 6 divided by 3 is 2. 33 divided by 3 is 11. Is there something in common? No. 2 and 11 do not have anything in common except the 1. So the GCF is the stuff on the side multiplied together. And coincidentally, we got 6 for our answer again. Again, you don't have to do both methods. Pick which one you like and stick with it. The downfall to the ladder is that you can only do it with 2 numbers. If you had 3 numbers, let's say you were trying to find the GCF of 8, 24, and 30, you would have to use the tree method. You could not use the ladder for more than 2. But if it's just 2 numbers, go for it.